Most of the students ask that they don't know the physical significance of derivative and physical significance of integration. They are able to integrate, they are able to find out the derivatives of functions, but they don't know why we find derivative or why we integrate. So in today's lecture, we just talk on the physical significance or what is the exactly meaning of derivative or integration is. But before going into the derivative and integration, we should have some background about functions and relations. Then limits of function. And then derivative of function. And finally, integration. See, here we find function. So we are able to understand all these concepts if we know what is function exactly is. And before going into the details of function, we should know what is relations exactly. And before relations, actually, we should know set theory also. So I can say, once we know set theory, we can go for relations. Once we know relations, we can go for functions. Then we can go for limits of function, derivative of function and integration. So this should be the sequence. So most of the students stop. So the first topic should be set. We'll just take a brief introduction about the set theory. What is set? Basically, set is a collection of distinct elements. What do you mean by distinct? Means repetition is not allowed. We can have, for example, set of subjects. Generally, set is denoted by capital A, B, Z, something like that. For example, A is the set of subject. It is something I have physics, chemistry, maths, English, and so on. So this is actually a finite set. There may be infinite set also. In mathematics, we come across the set of natural numbers, which is an infinite set. It is numbers from 1, 2, 3, 4, dot, dot, dot. So there is no end to the natural numbers. Then we come to the, you can say, set of integers. In integers, we cover 0, 1, 2, 3, as well as -1, -2, and so on. So then we go for the set of real numbers. Real numbers covers integers as well as fraction numbers. So this is about the sets. Now we just come to the next point. What is relations? So suppose we have two sets. One is set of persons and set of newspapers. Suppose I have persons like Ashish, Sunil, Ganesh, Ramesh, like this. And I have set of newspapers like suppose Lokmat, then Divya Marathi, Gaukari, Times of India, something like that. So these two are actually different. So this is a set of newspaper and this is a set of persons. Now there may be relationship between person and newspaper. What that relationship can be? Which person read which newspaper. For example, Ashish is interested in Lokmat and Gaukari. Sunil likes Divya Marathi. Ganesh goes for Times of India. Ramesh like Divya Marathi, something like that. So this is a, you can say, a relation. I can show that this is a relation such that from persons to newspapers. Suppose P is the set of person, N is the set of newspapers. So this is about the relation. So actually this is a separate set, this is a separate set, but these two sets are related to each other. जैसे कौन सा पर्सन कौन से न्यूज़पेपर में इंटरेस्ट रखता है. सो ये पर्सन्स थे और ये न्यूज़पेपर्स थे, लेकिन आशीष को क्या पढ़ना पसंद है, लोकमत पढ़ना पसंद है और गांवकरी पढ़ना पसंद है, तो आशीष का रिलेशन बन गया लोकमत से और गांवकरी से। इस तरह बाकी लोगों का किसी न्यूज़पेपर से क्या बन गया है, रिलेशन। सो हियर दिस इज अबाउट द रिलेशंस। नाउ सो हम बोल सकते हैं कि सेट्स के बीच क्या होता है, रिलेशंस होता है। Now let us come to the next idea, that is a function. Now function is a special type of relation where some restrictions are imposed on the relations. For example, I have a set A and I have another set B. Here A, B, C, D are the elements of set A and P, Q, R, S are the elements of set B. Now I have a special type of relation. Look at this relation. This is some speciality about this relation. Actually it is a relation, but we can say it is a function also. Why? This first set is known as a domain. इसको domain बोलते हैं. This is known as a codomain. Now we have a relation from domain to codomain. Generally in mathematics, this is our x and this is our y. So here what is happening? For every member in the domain, we have a particular member only or a single member in a codomain. See, A is only related with Q. B is only related with P, C is only related to R and D is only related to Q. There is restriction here. What is that restriction? Suppose I draw a dotted line here. This dotted line, it shows that D is not only related with Q but also related with S. Then this may be a relation, only relation, not a function. But I will erase this line. Now it is a function because every member in the domain is related to only one member of codomain. See, this restriction is not on members of codomain. Look at this. Q is actually having reverse relationship with A and D. Or you can say Q is having pre-images A and D. A is having image in Q, D is having image in Q, but Q is having two pre-images. So this is not a restriction with what? Codomain. But members in the domain have restrictions. If there is a single member like this, suppose this D, I draw the dotted line like this and temporarily I form a relationship of D with S, then this is not a function. This will be only a relation. So I should erase this line. So I think you got this. So I can say every function is relation, but every relation may not be a function. Okay. So looking into this, now we go for some functions used in mathematics. Very common functions we'll discuss. Suppose I have a function y is equal to x square. Now function we can discuss in another way also. We can show that this x is something independent. Y is dependent. In our set theory, we can say it is a domain, and here we can say it is a codomain. So, as far as set theory is concerned, this is x, this is y, or we can say function is from x to y. Now, this x is independent, means what? It will change. It is not dependent on anybody. But who will depend on x? Y will depend on x. If x changes, y is going to change by some formula. So for example, if x is equal to 1, y will be 1. If x is equal to minus 1, y is 1. If x is equal to 2, y is 4. If x is equal to minus 2, y is 4. How we get this? By applying the formula. We put the value of x here and we get the corresponding y. So if I show this x here, minus 1, 1, then 2, minus 2, and here 1, 4, suppose minus 3, 3, 9 and something like that. So I can draw arrows from minus 1 to 1, 1 to 1. Why? Because If x is minus 1, what is y? Y is 1. If x is 1, y is 1. So minus 1 is related to 1, 1 is also related to 1. What about 2? 2 is related to 4, minus 2 is also related to 4. 3 and minus 3 both are related to 9. So this is perfectly a function. Why? Because every member of the domain or every member from x side is related to unique member on the y side. But that restriction is not there on y. Here I can say that 9 is having two pre-images, 3 and minus 3. But 3 and minus 3 are having only one image, that is 9. So अगर इसमें थोड़ा भी ऐसा हो गया कि -2 से मैंने कहीं और जगह एरो ड्रॉ कर दिया, मतलब -2 किसी और से भी रिलेटेड हो गया, ऐसा एक जगह भी हो गया, तो ये फंक्शन नहीं रहेगा, ये क्या बनाएगा, बनेगा सिर्फ रिलेशन बनेगा. ओके, सो दिस इज अ बाउंड्री बिटवीन रिलेशन एंड फंक्शन. So this is a function. Now we can draw the graph of this function. I will draw the graph. Actually we take two axes. This is the x-axis, this is the y-axis. Suppose the x is 0, then 1, 2, 3, 4 like this, and here -1, -2, -3, -4 and so on. Now we want to draw the graph of y is equal to x square. So put x is equal to 0, we will get y is 0, we get this point. If x is 1 and -1, y is 1. For -2 and 2, y is going to be a 4. Somewhere here it is 4, here it is suppose 1, 2, 3 like this. So this is a y. Okay. For 3 and -3 you get what? 9. The value of y will be 9, it will be somewhere here. So I can draw this graph like this. I will just connect the points. We get the graph of function. I will write down here y is equal to x square. So this is the graph of function. Now, how to plot the graph then? Go on putting the values of x, different values of x, get the corresponding values of y. X की values आप लेके चले जाओ, इसमें put करके चले जाओ, आपको y की values मिल जाएगी. You will get the points like this. And just connect these points, you will get the graph of function. So in this way we can plot the graph. Now in previous standards, I think in 10th standard or in 9th standard, you must have gone for straight line. That is also a function. It is something in the form of y is equal to mx plus h. For example, y is equal to twice x plus 3 is a straight line. Now how will you draw this straight line? Same story. Here we say it's a y, here it's x. If suppose I put x is equal to 0, what I will get? Y is equal to 3. So for 0, I will get y is equal to 3. I will get this point. If suppose x is equal to 1, what will be y? It's a 5. So we will get here. So in this way, for x is equal to suppose -1, what I will get? If x is equal to -1, what will be y? Y will be 1. So here I will get the point. So I will just join these points and I will get the graph of straight line. This is y is equal to twice x plus 3. This line is having positive slope. Look at this. This is the slope of line and this is the y-intercept. So in this way we can plot the graph of straight line. So I think you got the idea of what is function is. This is again an example of function. Now we'll move to the next topic, that is actually most of the students ask what is exactly the derivatives. Now suppose I have a straight line. Now let us again consider a straight line. Just write down we are seeing the straight line. Suppose this is a straight line. Suppose its equation is y is equal to mx plus h. What is this m? It's a slope. Now slope means what? In Hindi we can say that how much you can say inclination is there to the positive x-axis. Now see, look at this. This is a y-axis. I can say it is an infinity slope. Now look at this line. Slope decreases. Look at this line, slope decreases. Look at this line, slope decreases. If suppose you are talking about the x-axis, it is having a zero slope. So in this way slope will change from 0 to infinity. Now this is a positive slope because you have to climb here. Now let us talk about the negative slope. Suppose look at these lines. I can say this is a negative slope, but slope is changing. So this particular line is having some slope. This m tells us about the slope. How to calculate that m? For calculation of m, we use a formula y2 minus y1 upon x2 minus x1. We take 2 points on the straight line, any 2 points. Suppose these are the 2 points. So this is suppose first point x1 comma y1, and this is suppose second point x2 comma y2. And in this formula, using this formula, we can find out the slope of straight line. So for this particular straight line, slope is uniform. Okay, but this may not be the situation with what? Regular or any other graph. For example, consider a function. Suppose this is a x, this is a y, and the graph is irregular like this. Okay, so it's what about the slope of this particular graph? It is not same everywhere. Look at this. Here we can say slope is 0. Here slope is negative like this. Here slope is positive. So somewhere slope is 0, somewhere slope is negative, somewhere slope is positive. So what you can say about this graph? Okay, this is a function. It is something y is equal to f of x. It may be some relationship like y is equal to x square plus 9x plus 2, something like that. Or y is equal to x cube plus 3x, something like that. They are not bothered what exactly the relation or what exactly the formula is, but look at the nature of the graph. The graph is not uniform, slopes are not same, slope is going to change everywhere. So it is not a situation like a straight line where slope was uniform and that was a 2 or m in general. So here slope is different. So I can say that for this particular x1 slope is something. For x2 slope is another, slope is having another value. For x3 slope is suppose 0. For x4 slope is negative. So this slope actually change with the change in x. So I should able to find out a relationship for the slope, something like that. Slope itself is a function of x, some g of x. If you put the value of x here, you will get the slope. For example, you are interested in finding out the slope at this particular part of the graph. What you have to put the value of x as x1. So you will get the slope here. Put the value of x as x2, you will get the slope here likewise. So slopes are different, and slopes are actually slope itself is a function of x. So slope is not same for every x. We go on changing the x, slope will change. So finding out this general relation of the slope, see, we started with y is a function of x. Then we find out a dy by dx, that is derivative of y with respect to x. That will give us actually a g of x. That will give us a general solution or general equation of slope. Look at this equation. Now in case of straight line, suppose y is equal to twice x plus 3. You will get dy by dx as 2. Means what? This slope is constant. It is not dependent on x. You go anywhere on the graph, slope will remain same. Look at this. Suppose I have y is equal to x cube plus 3x. Suppose this is the equation of function. So dy by dx in this case is 3x square plus 3. Looking at this expression, what you can talk about it? If you change the x, slope will change. For example, if x is equal to 1, what will be the slope? Slope will be 3 into 1 square plus 3. So it is 6. If x is equal to 2, you will get slope is equal to 3 into 4 plus 3. That is 12 plus 3. That is 15. So slope is not constant. Slope itself is a function of x. And this is actually a derivative of this function. Now this derivative gives us the slope of the graph. Actually, slope of the graph means If you are interested at particular point, what is the slope of graph? Actually, it is a slope of tangent to the graph at that particular point. So, physical significance of derivative is finding out the slope. Okay. So, for straight line type of curves, slope is constant. That's why derivative is constant. For this type of curves, slope is not constant. Slope is again a function of x. So we can find out the slope at different points on the curve by just substituting the value of x. So this is what the derivative is. Now, but how will you get the derivative actually for a given function? This is what we have done using the formulae. But how to get the formulae? For example, you must have seen that if y is equal to sin x, then dy by dx or derivative of y with respect to x is cos x. So from where these formulae actually came? For that we have to go for first principle. So if y is a function of x, then dy by dx is actually f of x plus h minus fx upon h, and of course this is in the limits s tends to 0. So this is actually the derivative by first principle. What we are doing here, if you remember the story of straight line, we have 2 points on the straight line. Suppose this is x2 and y2 and this is x1 and y1. What was the formula for slope? Slope was y2 minus y1 upon x2 minus x1. This was the formula for slope. Now, for a irregular graph like this, how will you find out the slope? Actually, how will you find out the general equation of slope? You have to consider somewhere you have a x, suppose here, and the function for this x corresponding y is f of x. Now, you will just move, suppose in this side, by a very small distance, suppose h. Now this point is x plus h. Now corresponding y is f of x plus h. So this is what we can say is a y2, and this is what x2 is. This is x1 and this is y1. So what was the formula? y2 minus y1 upon x2 minus x1. Same is the formula here. y2 minus y1 means what? f of x plus h minus fx. This is y2 minus y1. What about x2 minus x1? What is x2? Actually x plus h minus x. Now this x and this x will get cancelled, but we should follow some limitations. The limit is h tends to 0. So we get the final result. This is limit h tends to 0 f of x plus h minus fx on h. So this is what the formula for the derivative by first principle. So using this formula and having the knowledge of the limits, we can find out the derivative of most of the standard functions like sin x, cos x. For example, in case of sin x, how will you apply this formula? You have to write down like this: dy by dx is limit h tends to 0 sin of x plus h minus sin x upon h. Then you should use some standard results of limits, and you should have some basic knowledge about trigonometry like sin c minus sin d and all that. And by using this, you can solve this limit and you will get what? The final result as cos x. So in this way, we can find out the derivatives of most of the standard functions. Actually, the same concept we have used. This was for a straight line, but this is for any irregular shape where we have to use this idea and we have to solve this limit and get the answer. So in this way, this is actually a generalized slope is. So I think you got the derivatives, the physical significance of derivative. Now we'll move to what is integration is. Basically, integration is just a reverse process of derivative. For example, if you say dy by d, for example, you say y is equal to x cube plus 5, then what is dy by dx? dy by dx is 3x square. Now, the reverse process means what? If we integrate this 3x square, you should get the reverse, that is x cube. Means integration of 3x square, you will get a result x cube. But this constant will disappear when you find out the derivative. So you don't know about the constant, so you have to write down plus c here. So meaning is that if x cube is the function, its derivative will be 3x square. Or if it is the function, its derivative will be 3x square. And if you integrate 3x square, you should get this like this. So it is exactly a reverse process. But basically, if we do it like this, we just write down dy is equal to 3x square dx, multiply it. Then we integrate on both sides like this. Then what is integration of dy? We said it's a y. We take 3 outside, then x square dx. All of you know the formula that x raised to n dx is having integration x raised to n plus 1 upon n plus 1 plus c. This constant of integration. So 3 into x cube upon 3 plus c. So finally you get the result x cube plus c. Now this c we have to assume because this may be 5, this may be 2, this may be 0, anything. So we don't know this constant, so we have to add this. Actually, that's why it is known as an indefinite integral, because we don't know the value of constant here. Okay. So this is something that integration is just a reverse process of derivative. But for the physical meaning of the integration, we consider one more thing. Suppose I have a graph y is equal to f of x, and I am interested in the area from x is equal to a to x is equal to b. Suppose these are the points. This is x is equal to a, this is x is equal to b, and I am interested in this particular part or area under the curve. This I can find out using what? Integration. So if I find out a definite integral, that is y dx or fx dx from x is equal to a to x is equal to b, I will get the area a. So this is what the meaning of definite integration. So this definite integration is used for finding out what? Area under the curve. So I think you got the physical significance of derivatives and integration. Myself is Ashish Surana from Surana Engineering Classes, Nashik. Thanks for listening to the lecture.